Maybe I'm wrong, maybe I'm right. And what about this one? This one is the force is I want to write that minus. Anybody have some question? Okay. The force in this case is a Cx star. Again, the direction is opposite to the coordinate I set up. And this, in this case, is Vx star. And if I do this, what I have to do is I have to do the 1/2 minus kx squared minus 0. So I have minus kx squared 1/2. And I have 1/2 minus 1/2 Cx star squared. And that has to be equal to change of kinetic energy. Okay? So what is the kinetic energy, change of kinetic energy, what is the kinetic energy stored in a spring? What is the kinetic energy stored in a damper? What is it? Nothing. A mass spring or damper has a mass. Okay? The kinetic energy has to be 1/2 m dot squared. Okay? But this has to be same. So I can say 1/2 mx dot squared plus 1/2 kx squared plus 1/2 cx dot squared has to be 0. So again, if I differentiate, then I will get the same equation that we obtained. Okay?
Concerning the potential energy stored in damper, on the mechanism why there is Ex factor and the integral coefficient. Because the definition of work done is F dot and dr, but dx dot is not dr, right?
Yeah, me too. Me too. Strange. Good question. Let's think about it. How much energy can you make when there is a damper? Your question is very good, but we will end up with the same result, but we have to think about it. Have to think about it. So anyway, put your smart question in our bank for later use, right? Smart question must be stored in beautiful box will be used later. will go back, obviously, maybe sometime when we come out. We'll go back to our main story. Main story is saying that using energy principle we can obtain the governing equation, and also we can see many other interesting physical things that we did not observe when we use Newton's second law. Okay? In the text, there is the derivation that associates with spring mass system, but this spring has mass. Okay? And this spring will move. Right? And I assume the length of this spring is L. Okay? Okay. And I assume there is a spring stopping over there. And then the certain mass over here, the velocity of the mass over here would be, considering that velocity over here is 0, then velocity over here can be written like velocity v dy, this is dy, is equal to y over L x dot scale. And this is x. This is equal to this, and we move this, and 1/2 mx dot scale plus 1/2 kx scale, blah, 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 and differentiate with respect to time. And
after differentiate,
yeah, if I differentiate this, that is 1/2 2m x dot, right, and then x dot.
that is same as next time.
Yeah, if you differentiate this, we'll have to see x dot, and there's a 2. So, huh?
How can you write that?
Another surprisingly good question. And this one, I get 1/2 differentiate 1/2 2 k x dot, and we can eliminate x dot over here, so that we have the equation for free vibration, right? And you oppose that we cannot use the same approach as we did over here, as somebody said, and this, somebody said, you have objection to get this one to be this and this one to this, right?